अभिनंदन. अभिषेक, अक्षता, आनंद, अंजुम, बसवराज गडकरी, बसवराज वेदापुरी, भाग्यश्री.
Present, sir.
ओके. भक्ति, भारती.
Present, sir.
ओके. चेतन कुमार, दीपक, दिव्या, गढ़ प्रथमेश शिवाजी, ज्योति, किरण, किरण, लक्ष्मीकांत, मानतेश.
Yes, sir.
ओके. मोळे प्रेम, नागेश, नंदीश.
Present, sir.
ओके. पूजा पाटील, प्रमोद कुमार, प्रवीण, प्रियंका, संध्या, संतोष पुजारी, संतोष सोनार, शाहबाज.
Present, sir.
ओके. शफिया.
Present, sir.
राइट. श्रीधर सोलकनवर, सृष्टि, सिद्धार्थ
Present, sir.
वर्णेकर. ओके. सिद्धार्थ वर्णेकर, सिद्धार्थ पाटिल, सुप्रिया, वंदना.
Present, sir.
ओके. वसंत, वेदत्ता, योगेश, महेश, बाळेश, तैक मोहम्मद, प्रवीण, अभिषेक, ऐश्वर्या, अमानुल्ला, बंडुरकर तनय मोहनदास, भावराव, शोधन.
Present, sir.
ओके. देवाणवर अनिल कुमार शेकप्पा, नंद कुमार, प्रमोद, रोहिणी, रोहित, शशिधर, श्रीधर.
Present, sir.
ओके. स्नेहल, वैष्णवी, साईश, कार्तिकेयम. ओके. एनीबडी एल्स? राइट. Are you able to see the screen?
Yes, sir.
Okay. Let us take up the next example. First example was we discussed on T-mod register. The previous year this was the structure of the T-mod register that we discussed. Gate C slash T bar M1 M0. Gate C slash T bar M1 M0. Next example, take this example. Find the timer's clock frequency and its period for various 8051 base systems with the following list of frequencies. 12 megahertz, 16 megahertz.
Sir, sir, the previous problem mod to timer 2 ಅಂತ ಐತಲ್ರಿ ಸರ್, ಅದು ಏನ್ ಮಾಡ್ಬೇಕ್ರಿ? Timer 2 ಅಂತ ಐತಿ.
Mod to timer 2. I'll explain that. Mod to timer 2. Now mod to timer 2. Okay. What is the structure we got? Gate C slash T bar, gate, then we have C slash T bar, C slash T bar. Okay, then M1, M0, M1, M0. The same thing is repeated for timer 1 also. That is copy, paste. Okay, so upper 4 bits is for timer 1, lower 4 bits is for upper 4 bits is for timer 2. Right, we have one is that is TH0 and TL0, TH0 and TL0, timer 0. Okay, then this is TH1, TL1. Actually, it should be timer 1. Sorry that I have given it as timer 2. It should
Yes,
be
sir.
timer 1 ಆಗಬೇಕು.
ಹಾ ಸರ್ ಆಯ್ತಲ್ರಿ ಸರ್ ಅದ ಡೌಟ್ ಐತ್ರಿ.
ಇಲ್ಲ ಕರೆಕ್ಟ್ ರೀ ನೀವು ಹೇಳೋದು ಕರೆಕ್ಟ್ ಐತಿ ಟೈಮರ್ 1 ಆಗಬೇಕಲ್ಲ ಟೈಮರ್ 2 is wrong.
Okay, sir. Got it, sir.
No timers. Okay, fine. Right.
Yes, sir.
Okay. Find the timer's clock frequency and its period for various 8051 base systems with the following crystal frequencies: 12 megahertz, 16 megahertz, 11.0592 megahertz. Note down this example. I hope you all noted down. Is it noted down, students?
Yes, sir.
This is only the question part. Solution I will explain. What is the question? Find the timer's clock frequency. We have to find the clock frequency of the timer and its period. That is frequency. If you are finding, period will be reciprocal of the frequency. Correct? For various 8051 based systems with the following crystal frequencies. They have given the different crystal frequencies. Right? Usually we use the quartz crystal for oscillator in 8051 microcontroller. Right? Ceramic crystal, quartz crystal. We already studied about the oscillator in our first module. Then the crystal frequency, if it is 12 megahertz, what will be the clock frequency? What will be the clock frequency for the timers, right? And what will be the period of that frequency? Okay, period. What will be the clock frequency? What will be its period? For 12 megahertz, for 16 megahertz, what will be the timer's clock frequency? What will be its period? And if the crystal frequency is 11.0592 megahertz, what will be the timer's clock frequency and what will be its period? Okay, for 8051 base systems, right? Now, we have to find out for different crystal frequencies of 8051 microcontroller, what will be the timer's clock frequency and what will be the timer's period. Okay. Let us take the first one, 12 megahertz. If we want to find the clock frequency, then we have to divide the crystal frequency by 12. Okay, divide the crystal frequency by 12. That is 1 by 12 into 12 megahertz. 1 upon 12 into 12 megahertz. This we have discussed when we are discussing in the first module, right? So that is 12 clock pulses is equal to 1 machine cycle. All those details we have discussed in the first module, is it not? So 6 states is equal to 1 machine cycle, 1 state is equal to 2 clock pulses, right? Those details. Now here timer's clock frequency is 1 upon 12 into 12 megahertz. 1 upon 12 into 12 megahertz, that gives the timer's clock frequency. That is 1 upon 12 into the crystal frequency gives the timer's clock frequency. So it will be 1 upon 12 into 12 megahertz. So here it will be 1 megahertz. It will be 1 megahertz, right? Now this is the clock frequency. If we want the period, then what we have to do? We have to take the reciprocal of this. 1 upon f gives the time period, that is 1 upon 1 megahertz, that will be 1 microsecond. That is 1 microsecond will be the time period. Yes or no? Similarly, find for the second one for 16 megahertz and tell me the answers. For 16 megahertz, what will be the clock frequency and what will be the period? Tell me first tell me how much you're getting clock frequency and then tell me the period, time period. How much you are getting? Timer clock frequency for 16 megahertz. 1 upon 12 into 16 megahertz. Simple. 1 upon 12 into 16 megahertz. That is 16 megahertz divided by 12.
1.3 megahertz, sir.
1.33 megahertz. Correct. What about the time period? Time period is how much?
0.75 microseconds.
Correct. 0.75 microseconds. Very good. Therefore, the clock frequency is 1.33 megahertz and the time period is 0.75 microsecond. Right? That is for 16 megahertz. All of you are getting this answer? 1.33 megahertz clock frequency and time period as 0.7 microseconds. 0.75 microseconds. Fine. Then let us proceed with the third one. If crystal frequency is 11.0592 megahertz, find out the clock frequency first and then the time period. Bhagyashri, how much you are getting? Mat?
Sir, doing, sir.
Okay. Just you have to divide the 11.059 by 12. How much?
0.92 hertz.
Just check it.
0.92 hertz.
No. Tell me in terms of kilohertz. Kilohertz, how much it is? Keep it in engineering mode. Keep your calcs in engineering mode. And just go on pressing the engineering mode. You will get it in terms of kilo. How much it will be in terms of kilohertz?
921.6.
Exactly, 921.6 kilohertz. Okay, 921.6 kilohertz. Tell me the time period. Time period will be how much? 1 upon F.
1.08 microseconds.
Right, 1.085 microseconds. Write it to 3 decimal places. 1.085 microsecond. Okay. The frequency is, clock frequency is 921.6 kilohertz and the time period is 1.085 microseconds for 11.0592 megahertz crystal frequency of the 8051 system. Okay. I hope the example is clear to everyone. Any doubts here in this example? Any doubts here in this example? Okay, then we'll move on to the next part. Before coming to the TCON register, I want to explain the TMOD registers, what we had discussed in the previous class. TMOD register, right? So there are different modes of the timer that we discussed in the previous class. Which are the different modes? Can you tell me? Different modes of the timer. How
Mode
many
0,
modes?
mode 1.
Mode 0, mode 1. Only 2 modes. No other mode is there. There are 4 modes. Mode 0, mode 1, mode 2, mode 3. Timer mode 0, it is called as 13-bit mode, 13-bit timer or counter mode. Then timer mode 1, it is 16-bit timer or counter mode. Timer mode 1 is 16-bit timer or counter mode. Timer mode 2, it is called as auto reload timer. Timer mode 2 is called as auto reload timer. Then timer mode 3 is called as split mode timer. Remember, timer mode 0 is 13-bit timer bar counter. Timer mode 1 is 16-bit timer bar counter. Timer mode 2 is called as auto reload timer and timer mode 3 is called as split mode timer. Now let us study these individual timers, how they work. What is the mode in which they work and how they work. Okay, that we have to study here. The first one is timer mode 0. Timer mode 0, it is 13-bit timer bar counter. So as the name itself tells that it is 13-bit timer bar counter, it uses the upper 8 bits of the timer, that is THX is 8 bits and the lower 5 bits TLX, right? upper 8 bits of the timer and the lower 5 bits of the timer. Total how many bits? 5 plus 8. 5 plus 8 is 13 bits. They make use of 13 bit out of the 16 bits, right? They make use of 13 bits out of the 16 bits. Now to this timer, which is using 13 bits only, we are applying the pulse input. Pulse input is applied. Okay, from the clock pulse is applied here to this timer. So as the clock pulse is applied, it starts from all 0 bits. All the 13 bits are 0. It starts counting. First is 1, 2, 3, 4. Right? It starts counting up till all the 13 bits are high. It starts from all the 13 bits low to all the 13 bits high. Okay, so once it goes to all 13 bits high, right, next time it has to count from all ones to all zeros. That is called as what condition? Overflow condition. It is called as overflow condition. That is, all the 13 bits high, when it goes from that state to all the 13 bits is low, or all the 13 bits zero. This condition is called as overflow condition. When there is a overflow, this flag, timer overflow flag, will be set. This flag is called as timer overflow flag. You will be studying next is in tick on register. This overflow flag will be set, which indicates that there is an overflow, and an interrupt will be generated. An interrupt will be generated, which is nothing but the interrupt of the timer. Right? If you want to use the timer for interrupt purpose, right, then you have to set the timer starting value, right, then allow it to count by applying the clock pulses. Once it reaches that target, it will overflow. When there is a overflow, there is timer overflow flag setting high. This will go high and an interrupt is generated. So like this, we can use the timers for generating the interrupt also, in addition to making use of the timers for generating the delay. Correct? So we are setting from all zeros to all 13 bits high. When it overflows, the overflow flag is set high. When there is a overflow flag setting high, the interrupt will be generated. Okay. This is timer mode 0, that is 13-bit timer bar counter. Next is timer mode 1. Timer mode 1 is 16-bit timer bar counter. 16-bit timer bar counter. It uses all the 16 bits of the timer bar counter. It uses all the 16 bits of the timer bar counter. That is TLX 8 bits, THX 8 bits. Timer low 0 8 bit, timer high 0 8 bit, or timer low 1 for timer 1 8 bits, timer high 1 for timer 1 8 bits. Okay, then the pulse input is applied, clock pulse is applied to this timer for counting purpose. It starts to count. How it counts? It counts from all zeros. Then next state is 1 2 3 4 5 6 7 8 9 A B C D E F. Like this, it counts up till all the bits are high. All the 16 bits are high. All the 16 bits are high. That is from all zeros to all ones. That is 0000 to FFFF. That is the value that it counts from all zeros, 0000 to FFFF. Okay, that is from all zeros to 65,350, approximately 355 counts. It will count. Okay, that is from all zeros to all 16 bits high. Then when there is a overflow from all ones to all zeros, then the overflow flag will be set high, which indicates that there is a overflow condition. When this flag is set, we will come to know that there is a overflow occurring. Then it will generate an interrupt. Once immediately as the overflow flag is set, there is an interrupt occurrence. There is an interrupt generated, which indicates there is an overflow, and the interrupt, or if we wish to make use of the timer for interrupt purpose, then we can make use of the timer for the interrupt generation. Then the third mode is timer mode 2. It is called as auto reload timer. Auto reload timer. So here the timer high THX, it loads the starting value into the timer low. Right? This is the symbol which is indicating that the timer high, it is loading the starting value into the timer low register. Then the timer low register, when the clock pulse is applied to this, it starts to count from all 8 bits zeros. It goes on counting from 1 2 3 up till all the 8 bits high. That is up till FF 255. Okay, so when it counts from all ones to all zeros, when it is, there is an overflow condition, overflow flag will be set, and at the same time the starting value whatever was there in THX, that will be loaded into TLX. What is happening here? There is two timers. One is for two timer registers here, TLX and THX. The timer high register is storing the starting value whatever we want to start from, depending upon the delay requirement. Depending upon the delay requirement, that is stored in TLX. Then as the clock pulses are applied to this, it starts to count. It counts from all the 8 bits low to all the 8 bits high, or whatever the starting value, from that starting value to all the 8 bits high. Then there is an overflow condition occurrence. When there is overflow, the timer overflow flag will be set. TFX flag will be set. For timer 0, it is TF0. For timer 1, the timer overflow flag is TF1. When it is set, the interrupt will be generated. Then at the same time, whenever there is an overflow, whatever was the starting value in THX, that is reloaded into TLX, and then it starts to count again. Then it starts to count again. This is how it is counting in the timer mode to auto reload time. It is called as auto reload timer because the starting value is automatically reloaded into TLX register from the THX register. That is why it is called as auto reload. It is automatic reloading. Clear here? This mode is convenient because we can store any starting value in THX and load it into TLX. We can get any delay requirement. But for other timers, what is happening here? It starts from all zeros to all ones, right? But this is adjustable. Timer mode 2 is convenient because we can load any starting value into TLX register and we can make it to count. Okay. Then come to the last one. It is split mode timer. Split mode timer or timer mode 3. Here we are using two timers in parallel. Two timers in parallel. Simultaneously we are using two timers in parallel. We are applying the pulse input to the TL0, right? It counts from all zeros to all ones. When there is overflow, TF0 will be set high. There is an interrupt. Then second one, for the second timer, we are applying crystal frequency divided by 12. Suppose just now we calculated for 11.0592 megahertz crystal frequency, the clock frequency that you are getting is f by 12, that is 921.6 hertz. Okay, depending on that, the clock pulses are applied, and this TR1 bit in TCON, it is for making the timer on. We are studying that in the next part. TR1 is a timer 1 run control bit. TR1 full form is timer 1 run control bit. I hope everybody are following here, right? Timer 1 run control bit. When this bit is set, the switch is closed. The switch is closed and the clock pulses are applied. The timer starts to count. It counts from all zeros to all ones. When there is overflow, the overflow flag will be set and the interrupt will be generated. Clear here? That is, we are getting two timers in parallel. One is from the TL0 register, one is from the TL0 register, another one from the TH0 register. Okay, that is why it is called as split mode timer. We are getting two timers in parallel. They are working in parallel. Fine, then these are the four modes, that is timer mode 0, timer mode 1, timer mode 2 and timer mode 3, and they're working. Okay, but remember the working of these timer modes, how they work in mode 0, mode 1, mode 2 and mode 3. Sometimes they're asking the explanation of these modes in examination. Most of the times they have asked timer mode 2, and they may ask the other modes also. Explanation of the timer working in mode 0, mode 1, mode 2 and mode 3, right? Then we'll move on to the next part, that is TCON register. TCON register. So in the TCON register, we are having 8 bits. It is bit addressable. TCON register is bit addressable. Okay. That means, what is the meaning of bit addressable? Can anybody tell me meaning of bit addressable? What is the meaning of bit addressable? T-mode, whether it is bit addressable or byte addressable. T-mode.
Bit addressable.
T-mode is TMOD is not bit addressable. TCON is bit addressable.
Byte addressable.
TMOD is not, it is byte addressable. TMOD is byte addressable. We cannot access individual bits from the TMOD register. Whereas TCON is bit addressable. We can access individual bits. We can access individual bits from the TCON register. Okay. So which are the different bits here then? TF1, TR1, TF0, TR0, IE1, IT1, IE0, and IT0. These are the bits of the TCON register. It is called as bit structure, bit pattern or bit structure. It has 8 bits. It is bit addressable, which are the various bits: TF1, TR1, TF0, TR0, IE1, IT1, IE0, and IT0. Okay. The first bit, it is called as timer 1 overflow flag. Timer 1 overflow flag, TF1. So this timer 1 overflow flag is set whenever there is a overflow condition. Just now we saw the timer mode operations, right? Whenever there is overflow condition, the hardware circuit will set the overflow flag to 1. It will make the overflow flag to become equal to 1. Then when there is a overflow condition occurring, the interrupt is generated, right? Interrupt is generated, we know that. And when the routine for that interrupt is serviced, the routine for that interrupt is serviced, providing service to the required interrupt. Suppose say some operations, some jobs, some tasks requiring some interrupts, then they are requiring some service. So that service can be provided after generating the interrupt using the TF1 flag. Fine. Next bit, TR1, timer 1 run control bit. It's called as timer 1 run control bit. Timer 1 run control bit means it is used to turn on and turn off the different timers. There are 2 timers. To turn on the timer 1, it is used. TR1 is for timer 1 and TR0 is for timer 0. If you want to turn on the timer 1, we have to make this bit high. Okay. How we are making that bit high? I explained in the previous class. Set bit TR1. Set bit TR1 using that instruction. Set bit TR1. SETB TR1. Then TR1 will become equal to 1. This is a software method, right? Then clear TR1. Clear TR1. We are making the TR1 0. We are turning off the timer. Okay. This is timer 1 run control bit. Then next is TF0. The same as that of TF1. This is for timer 1. This is for timer 0. This is timer 1 overflow flag. This is timer 0 overflow flag. Whenever there is the overflow condition occurring for timer 0 used in any of the modes, either in mode 0 or mode 1 or mode 2 or mode 3, then the timer overflow flag will be set by the hardware circuit. Once it is set, then the interrupt is generated. To provide service to the interrupt, there is a small program that is executed which will provide the required service for the various jobs or for the various tasks once the interrupt is generated. Okay. Then the next bit, TR0. This is same as TR1. TR1 is for timer 1 and TR0 is for timer 0. It is called as timer 0 run control bit. Timer 0 run control bit. This timer 0 run control bit is used to turn on and turn off timer 0. It is used to turn on and turn off the timer 0 using the instructions SETB TR0 for turning on the timer 0 and clear CLR TR0, that is TR0 will be 0 for turning off the timer 0. Next one, IE1. IE1 is called as external interrupt 1 edge flag. External interrupt 1 edge flag. Whenever there is an interrupt detected, whenever there is an interrupt occurrence, right, external interrupt edge is detected, that time this IE1 flag will be set. Whenever there is a interrupt detection, this IE1 flag will be set. External interrupt 1. Once it is detected, right, its edge is detected, that is low going edge or its low going pulse is detected, then this IE1 flag will become equal to 1. Next, IT1, that is interrupt 1 type control bit. It is called as interrupt 1 type control bit, IT1. This interrupt one type control bit is to trigger the interrupt. That is to generate or to activate the interrupt. Once this IT1 flag becomes equal to 1, the interrupt will be generated. Okay, the interrupt will be triggered or it will be activated. That is low edge interrupt, external interrupt, or low level interrupt will be triggered or it will be activated once this bit becomes equal to 1. It is a control bit. Right? Flag bit means what? They indicate the status. There are two types of bits here. One is flag bit, another one is the control bit. Flag bit indicates the status. That is whenever any operation occurring, it indicates the status. We have different flags: carry flag, auxiliary flag, overflow flag, parity flag. What is their job? To indicate the status. Whenever there is a carry generated, carry flag will become equal to 1. Whenever there is overflow condition, overflow flag will become equal to 1. So these are the flags. Then control bit means they are used to trigger some actions. They are used to trigger or activate certain actions. Those bits are called as control bits or control flags. Then this IT1, it is interrupt type 1 control bit. It is used to trigger the interrupt or activate the interrupt. Next is IE0, external interrupt 0. Look here, how to remember. E is for external, I is for interrupt, then 0, edge flag. External interrupt 0, edge flag. Again, whenever there is external interrupt 0 occurring, then IE0 flag will become equal to 1. Whenever the external interrupt 0 is detected, the IE0 flag will be become equal to 1. Next, IT0. IT0. This is interrupt type 0 control bit. This is same as IT1. This is same as IT1. IT1 is interrupt type 1 control bit. IT0 is interrupt type 0 control bit. Interrupt type 0 control bit. Again, this is a control bit. Remember, control bit is used to trigger certain actions or to activate or generate certain actions. So it is interrupt type 0 control bit which is related to interrupts. Hence, the interrupt will be generated or activated or triggered whenever this bit will become equal to 1. Fine. This is all about the bit pattern of the TCON register. Remember, the TCON register full form is timer bar counter control register. TCON full form is timer bar counter control register. Timer bar counter control register. This is the full form of TCON register, which is bit addressable register. Clear here, students? This bit structure of TCON register is clear. In examination, they ask the bit pattern or bit structure of these registers. There are various registers, special function registers. TCON is there, right? SCON is there, IE register is there, IP register is there, right? PCON register is there, TMOD register. In examination, they are going to ask any of these, whatever I told now, any among these registers may be asked in examination. Okay, definitely one or two registers may be asked in examination. So make them perfect. Okay. Next, we'll move on to one more related topic, that is initializing and accessing timer registers. How to store the value into the timers or timer registers, and how to make the timers to work, or how to make the timers to count for counting purpose, right? So there are some steps here that we have to remember in order to initialize these timer registers and in order to access these timer registers. Which are these steps? The first step is timer registers are initialized at the beginning of the program to set the operating mode. If you want to set certain mode of operation, that is mode 0 or mode 1 or mode 2 or mode 3, then we have to make use of the TMOD register. We know that. Already I discussed an example on TMOD register, correct? TMOD is the first register initialized because it is setting the mode of operation. How we have to set the mode of operation? Use move instruction. Move TMOD comma hash 00010000B. B stands for binary. If it is H, it is for hex. Okay. Now this value is how much, students? Can you tell me? 0001, then 4 zeros B. How much is this value in hex? How much is this value in hex? 0001 is how much? It is 1. 4 zeros, it is 0. 10 hex. That is move tmod comma hash 10 hex. Either you can write it as tmod comma hash in binary, or you can write it as tmod comma hash in hex.
Right? Either of these two is possible. Which mode is used here? Can you tell me which mode is used? See, gate C slash T bar M1 M0, gate C slash T bar M1 M0. You have to remember the bit structure of TMOD register. Gate
Mode 1, sir.
mode 1, exactly. Because 0 0, gate is 0, C slash T bar is 0, that is for timer. M1 is 0, M0 is 1. M1 is 0, M0 is 1. 0 1 means it is mode 1, decimal 1. 0 1 is binary. In decimal, if you convert it, it is 1. It is mode 1. C slash T bar is 0 and gate is 0. This is the first step. Then second step is, if the initial count is necessary, then the timer registers TL1 bar TH1 must also be initialized. That is, we have to initialize in which register we are going to store the starting value. The starting value should be stored in TH1 and TL1 registers. Okay. Suppose if you want the time of 100 microseconds, then we have to store 100 counts. The value that we have to store in timer registers is 100. So depending upon how much delay we want in terms of microseconds, that time, that much amount of count should be stored in the registers. Suppose say we want a time delay of 50 microseconds, then we have to store 50 counts in TL1 and TH1, TL1 or TH1. Okay. Suppose say we want a count of 75 microseconds, and the starting count that we have to store in TL1 bar TH1 is 75. This is how we are initializing the timer registers TL1 bar TH1. You'll come to know that we are taking examples on this. Then I'll explain you there how we are loading the starting value in TL1 and TH1, how to calculate that starting value. So the correct value is minus 100. So minus 100, that is FF minus 100. If you do, you'll be getting FF9CH, right? FF minus 100 counts. If we do, we get the value FF9CH. This is the starting value that we are going to store into the TL and TH registers. That is, timer high we are storing FF, timer low we are storing 9C. The starting, what is the maximum value of count? FF 16 bit, for 16 bit, right? FF minus 100 if we perform in hex, then we get FF9C hex. FF9C hex. Okay, this is the starting value that we have to load into the timer registers, TH and TL registers. Which are the instructions we are using for that? Move TL1 comma hash 9CH, that is timer low, lower 8 bits, 9CH. Then move TH1 comma hash 0FFH, that is the higher byte, higher 8 bits, TH1. Move TH1 comma hash 0FFH. We have to use 0, just simply don't write it as 0FFH, because if you are writing as only hash FFH, the microcontroller will not understand whether it is an ASCII letter or an ASCII digit. Therefore, to make the microcontroller understand that it is a ASCII digit, it's a digit and not a letter, we have to precede FF by 0. The timer is started. We know how to start the timer. I told the instructions, that is set bit TR1. Set bit TR1. This is timer 1 run control bit to start the timer. This is the third step. And the fourth step is wait JNB TF1 comma wait. Once the timer is started, it will start to count. It starts from, say, if all the bits are 0 first, then it will start from all zeros to all ones, right? That is from 00000 to FFFFH. Once it goes from FFFFH to 0000, there is overflow occurring. Once there is overflow, the overflow flag will be set. TF flag will be set. That is, we are monitoring this overflow flag using the instruction JNB TF1 comma wait. This is the instruction that we have to use. That is JNB jump if no bit. Jump if no bit means if TF1 is 0, jump to wait. Again, the timer counts. Again, check for TF1. If it is 0, again go to wait. Jump till wait. Next time, suppose if there is an overflow condition, then TF1 will become 1. Then this condition is false. Condition is false. JNB jump if no bit. But TF1 is 1. It is not 0. So it will not jump to it. It will come out of the loop. It will come out of the timing operation. Then stop the timer. We have to stop the timer. To stop the timer, we have to use the instruction clear TR1. CLR TR1. And we have to also clear the overflow flag. Overflow flag should be cleared in order to make use for the next operation, next timer operation. So clear TF1, clear the overflow flag, right students? So these are the various steps that you all have to remember for initializing and accessing timer registers. The first step, we have to load the tmod register depending upon the timer and its mode. Second step, load the starting value in TL1 and TH1 depending upon the calculation. Then third step, we have to start the timer using the instruction set bit TR1. Fourth step, we have to monitor the overflow flag whether it is 0 or 1 every time using the instruction wait JNB TF1 comma wait. And fifth step, once there is a overflow condition, we have to stop the timer using the instruction clear TR1 and also clear the overflow flag using the instruction clear TF1. Fine. So in today's class, we discussed an example. We discussed the various timer modes, mode 0, mode 1, mode 2, mode 3. Then an example was discussed to calculate the clock frequency and its time period given the system frequency or the microcontroller frequency, crystal frequency. We also discussed the timer bar counter control register, which is bit addressable register. Then initializing and accessing timer registers, which are the steps to initialize and access the timer registers or to use the timer for its operation. Okay. Any doubts here, students? Any questions? I hope everybody understood. I hope everybody understood.
Yes,
Bharti?
sir.
Good. Bharti? Bhagyashree? Mantesh?
Yes, sir.
Understood, Mantesh? Clear with the concepts?
Yeah. Yes, sir.
Okay.
Clear, sir.
Okay, fine. Nandish?
Yes, sir. Understood, sir.
Good. Shabaz?
Yes, sir. Understood, sir.
Okay. Shafia?
Yes, sir. Understood.
Any questions, Shafia? Anything not understood?
No, sir. Understood, sir.
Supriya? Supriya?
Yes, sir. Understood.
Okay. Shodhan? Shodhan?
Yes, sir. Understood.
Any questions, Shodhan?
No, sir.
Okay. Sridhar? Sridhar?
Yes, sir.
Clear, Sridhar? Any questions?
Yes, sir. Clear, sir.
Okay, fine. Okay, in the next class, we'll continue with the timer mode that we'll discuss. Many timer modes are there, and there is a programming part. First, we'll be able to discuss in assembly language, and then it will be in the C language, that is timer bar counter programming. Okay, that we'll take up in the next class. Thank you.
Sir, the list of roll numbers, can you tell me?
1 minute, Shodhan, 1 minute. I'll come to that. Just a minute.
Okay, sir.
1 minute. Just a minute. Hold on.